The first Autonomy and Sustainability Summit was organized by NFAS and held in Oslo. In June 2019, autonomous ships in Norway started with the EU-funded Unity project from 2012.
We live in a time of great change. The pace of change is faster than ever before. Autonomous shipping redefine our industry.
Technological progress will never be as slow as today.
Main driver for innovation has always been regulation. That's when we start to talk about maritime autonomous surface ships and have a more holistic approach.
If you want, our vision is one of zero accidents, zero waste, zero pollution.
Therefore, please be bold in your ambitions.
The times of COVID, businesses were running slower. They sat at the desks thinking what it is that we can do to make shipping even greater. Autonomous vessels will help us to achieve the target.
Our goal is the same as always, safety and sustainability.
What we have seen is inherent complexity, which is overwhelming. Concept of operation is an important first step.
These vessels that are being built now are not a threat or competitor to existing vessels, right?
We are having 80,000 ships, a tsunami of different solutions.
We are bringing ship and shore closer together with the exchange of data, but it is also beneficial to the seafarers.
I believe we are at the pivotal moment. We must work together.
There is an ongoing commitment to make this happen. Common ownership. Master responsible for a mass.
Green Deal challenges also. Opportunities. Alternative propulsion. New technology, the great potential.
The people, profit and planet, you know?
More projects materializing. The focus might have changed a bit.
Most ships are candidates for autonomy.
Is that going to be launched today? Operator is a conscious driver.
We do not have to find the perfect failure-proof solution. We also need standardization.
Our goal is clear. Make safer, greener and more profitable. For this is complicated. The switch has to be gradual and careful. It is conditioned by layers of safeguards. Safely together.
Yes, ladies and gentlemen, distinguished guests, colleagues and friends. Again, it is a great pleasure to welcome you all to the 6th Ship Autonomy and Sustainability Summit, co-hosted by the Norwegian Forum for Autonomous Ships, the European Commission, and Norrshipping. And a special welcome to our new guests that weren't able to attend the first part of this meeting. As mentioned in my opening speech, this is a gathering that continues to grow in relevance, urgency, and global significance. We are here not only to share knowledge, but to shape the future of maritime autonomy and sustainability together. This year's theme, While We Wait for the Mass Code, What is Happening Outside IMO, reflects a critical reality. While the International Maritime Organization continues its important work towards a regulatory framework for maritime autonomous surface ships, with a voluntary guide expected in 2026 and a mandatory code by 2030, the world is not standing still. As mentioned earlier, innovation is already happening and is happening fast. In this summit, we are exploring the dynamic developments taking place beyond the scope of the mass code, in areas where autonomy is being applied today, not tomorrow. From large, uncrewed surface vessels to urban and coastal ferries, we are witnessing a quiet revolution in how ships are operated, managed, and integrated into our transport systems. So far in our summit, we have focused on these very developments in non-mass autonomous ship operations, from the rise of large, uncrewed, and remote-controlled USVs to autonomous passengers and car ferries, a segment experienced rapid growth, and public interest. This second part of the summit will now take us into the heart of one of the most transformative and controversial forces in autonomy, artificial intelligence. First, we will explore the current state of AI in autonomous ship operations, from object detection to predictive maintenance and control system. AI is both a powerful enabler and a complex challenge. We'll ask, where is AI being used? Is it a solution or a risk? And how do we ensure it serves the public good? And thereafter, we will then address the evolving role of the human operator. As automation and AI advance, the human element remains essential, not just as a fallback, but as a partner in decision-making. We will also confront the regulatory, ethical, and geopolitical questions that come with AI's growing influence in maritime systems. And I would also like to repeat again, this summit is not just about showcasing progress. It is about asking the hard questions, challenging assumptions, and building bridges between technology, regulation, and society. So, to share your insights, your concerns, and your visions for the future, whether you're a policymaker, a technologist, a ship owner, or a researcher, your voice matters in this conversation. So if you have any questions that you see when we're having these panels going on, don't just have them stay in your mind, ask them, because at the end of every session, we will also have a small period where we can have a Q&A, and you are welcome to come with your questions then. And also now, during this second part, we will make use of Slido, and I would like to introduce this now, as some of you were not taking part in the first, so you just, if you grab up your telephone, do you have the Slido? Oh, okay. You could use this barcode then, and you could just use a camera on that, or you could just write it into your web browser, slido.com, and just add this number you find beneath. And once you get in there, then you can start with the first question, is who you represent. This is, we had the same question in the first session, but this is just so we also get the new people here in the audience. So I'll give it a few more seconds, and then we go on to the next question. Okay, next question. What impact do you expect the MAS code under development in IMO to have on deployment of MAS on a larger scale? None, little, no opinion, major, and so on. Okay, and then I think we go to the next one. The final question. Do you think MAS will become as safe as or safer than conventional ships? Okay. And then, finally, I just want to thank you all again for being here, and then welcome to the second part of the 6th Ship Autonomy and Sustainability Summit. And I will now leave the floor to Ørnulf Rødseth, who will be the moderator for our next session, dealing with artificial intelligence. Thank you very much.
Okay, welcome again. And to the panel of the usual suspects. I have been able to gather some of the kind of leading international voices, at least, and experts on mass autonomous ships from around the world. So I would like to welcome each of you. Yin Kim, Vice President of CRISO, Korea Research Institute of Ship and Ocean Engineering. Please. Hideyuki Ando is Director of Mono Hakobi Technology Institute in Japan. You can bare sitte der. Sean Pribble, partner, Holland and Knight from the United States. Jakob Terling, Principal Administrator, European Commission, DG Move. And finally, but not the least, Øyvind Smogli, CEO and CTO of Seabus in Norway. So we have two panels in this last part, and in this panel we will try at least to kind of explore how AI is impacting international and national strategies and developments in mass and autonomous ships in general. The next session will go more deeply into some of the problems, both technical, human factor, security, stuff like that. So we will try to look more at the broader international perspective here. And I think I discussed a bit with Øyvind. What is actually AI? And he was very eager to give an answer. So I think I give the word to you, Øyvind.
All right. Thank you, Ørnulf. Yeah. So Ørnulf gave me this mic because he was afraid I would talk too much, and this one's easy to mute. So yeah, if I go too far, then mute me. All right. So what's AI, right? And I think a lot of us kind of equate AI with data-driven AI or machine learning. But actually, if you look at the definitions, it's more. AI is really a system that can exhibit human or animal-like behavior and can make decisions under uncertainty. And that gives room for quite a lot of different types of systems. And the kind of public perception of AI has developed over the years. Right? So going way back, it was expert systems, like belief networks. Then you had the kind of first versions of machine learning working on big data analytics. Then you had the kind of explosion of AI in the public domain with deep neural nets, and where they really became useful in many applications like machine vision. And where also things like reinforcement learning enabled computers to beat the world champions in chess and Go. And now the big hype is generative AI. So the large language models like ChatGPT and diffusion models that generate images. So, and I hope no one really believes that ChatGPT will pilot our ships. Although some people give much more capabilities to these large language models than they really have. But I think the point is that all of these different types of AI that I just mentioned, and of course there's many distinctions there as well. I mean, you have supervised learning and unsupervised learning and so on, but it's all narrow AI. It's super useful if it's deployed in the right way and on the right problem. But the user needs to know its capabilities and its limitations. And of course, in the case of the data-driven systems, you need to have control of the data. It's a good old shit in, shit out there as well. So it's important that it's narrow, right? So this hype about AGI or artificial general intelligence, honestly, that's a Silicon Valley hype. It's something put on a table to fund these big companies, and it's nowhere near on the horizon. With the current technologies and solutions and algorithms we have, you will not see general artificial intelligence, I assure you. So, of course, new technologies may come, like new computing methods and new algorithms, but so far, I have no belief in that, and definitely not on board autonomous ships. So how can we use AI? So where is it used? And it's easy to think about, what do you deploy on board the ship in terms of, for example, an autonomous navigation solution or for predictive maintenance. But people use AI for different applications, right? So developers use it in coding. You can be very efficient as a developer with AI tools. The danger here is if you don't understand what you code anymore. If you fall into the trend of vibe coding and just let the machine do the work, I would certainly not put that into a safety-critical application. We see increasing use of AI in documentation and procedures, which can be a good idea. Large language models are good at producing text, but they don't have any understanding. So I recently talked to a colleague from Equinor, and he was concerned because he saw vendors starting to write procedures with LLMs. Right? So if you flip the sequence of 2 steps, you can blow up a platform. Right? The LLM wouldn't know. You can use it in assurance. So that's one of the things that we're working on also in CBUS, looking at how we can deploy, for example, reinforcement learning in the assurance processes. And of course, finally then, you can use it in your systems, your active systems on board, like in navigation. But I would also like to make the clear distinction that AI doesn't have to be black box machine learning. So the way we work with our AI in ZBUS, it's a very modular, transparent system, a well-defined architecture, small modules that can be explained by themselves, and some of them contain some machine learning. So there's a machine vision algorithm there, but there's also a lot of traditional, I would say, control engineering and best practices, and that can also exhibit very much human-like behavior in navigation and fall under the wider definition of AI. So yeah, let's for the discussion now. I guess Ørnulf wants to dive us more into the data-driven side of this, but it's yeah. Let's have in mind that AI is a broad umbrella term that can easily be misinterpreted.
Yeah, I think actually I would like to take a round in the panel and hear what do you think is this also your view of AI? Is it different? Is this a national, yeah, kind of agreed on way of thinking about AI as mainly data-driven, but also with possibilities in other areas? So Ando, for instance, you have the microphone.
Yes, thank you. I basically fully agree what Øyvind described. Yes, it's almost like a same perception for us, and I mean, probably there are not that like international differences in about actually what is AI and this history and the technology and also limitation. Probably I think we share same understanding. That's so. But of course, well, it's a bit difficult to say something different from Øyvind. But I mean, it's actually we have a lot of experiences. I mean, to try to develop AI in the past, and still actually still somehow we are believing in that. The human knowledge is, in some cases, superior than AI. That is what still we are thinking. If we limit some context, like let's say, okay, something like a design. It's a very human creativity needs design. If we limit the context, set a proper boundary, probably human could be superior. So still, we are rather like, of course, probably many of you believe in the human performance in superior than AI. So if it's like a generative general AI thing, that I mean, still we are trying to find out what are the appropriate place that the AI fit to, and where the human performance, I mean, human capability superior, and how to combine those superiority between human AI, the rather interests. I mean, not only focusing on AI. That's my personal view.
Sean?
Thanks. So I'm here to give the U.S. perspective. Thanks again for the invitation. I'm an attorney in Washington, D.C., formerly lived in Norway, and I'll just touch on what I saw during my time in Norway several years ago, was how quickly Norway had moved on the maritime and vessel side of autonomy. Truly impressive. The U.S. is still very envious of how quickly Norway can move with advanced technology on their vessels. The distinction now with AI is that this has now become a national priority. And what I mean by that is it's artificial intelligence. So the maritime piece, I'll touch on that later perhaps, but just to speak a bit on where the U.S. is with AI, again, it has the attention of the White House and Congress and across the industry, both from a defense perspective as well as commercial application. We do not have a universal legal framework yet in the United States for AI, but it is moving very quickly. So the distinction for those who don't know about the U.S. Legal system is that we have 50 states and then a federal government as well. The concern right now in the United States is making sure that we don't have 50 different legal frameworks for AI, which is incredibly important for vessel operations. That's why in the United States, vessel operations generally lie at the federal levels so that ships can come in and out of port and make their voyages and passages without having to have a bespoke set of laws in each state. That's setting aside, of course, some certain environmental laws in places like California. But this has become a priority in Congress. We in our law firm have worked closely with Congress and developers in this space, again, both on the defense side but also the commercial side. I would say that this is where the U.S. hopes to lead. For those that may not have been following this, the U.S. has publicly said that they want the United States to be the center of worldwide AI. And this is something that we've seen executive orders from President Trump related to this. We have seen Congress now drafting bills to address this. We've seen task force over the past year looking to identify close to 100 items that they feel are imperative. Really, it's about governance, but it's also about public trust, which I think was mentioned earlier.
Can I follow up? Because for me, it sounds like AI has kind of become a central ingredient in establishing a kind of technology. Yeah. Yes.
So we're seeing it from every front, like I mentioned, defense, commercial, but also academia. I think it's going to be a strategic imperative. Then it will flow to industries like maritime. We're already seeing it in the transportation sector and in aviation and road much quicker than in maritime. We are seeing use cases in the United States, mostly with advanced automation, not necessarily full AI. But we are moving towards that, and so this would give the framework that the maritime industry could look to.
Yep, excellent. We'll come back to that for the others also. But Jakob?
Thank you. Good afternoon to all. Thank you for that question. And that was the first question I asked myself when we designed this panel. Thank you, Øyvind, for trying to take me out of my confusion. I should say I certainly will never say I know AI. I'm trying hard to understand what it is and the difference with machine learning. But I asked ChatGPT in preparation for this. I will not reveal what the answer was. But I'm like still to use what little I have left up here. So I'm coming to that as long as it is supporting and enhancing what maybe those that have to take decisions or are in charge are doing, it's probably a helpful thing. And it's nothing new in that sense. That is part of natural development. But I have myself, I speak personally now, difficulties when we cross that line and what it then means. And I will come back to it, but I hope that it's not another hype. We started with a hype for this. We are landing on our feet, and that this is just not another hype that will deviate our concerned or concentrated efforts to make something purposeful here. I'll stop there because we will probably come into many other things.
Yeah, and I think also just a comment from me that in EU we got the AI Act, which at least gives a bit more conservative approach to AI than we see in the United States, I think. But we'll come back to that. Ian Kim?
Yes. What is the AI? It's the simple but very difficult question. Actually, Korea, we ongoing the Korea Autonomous Services project. In this project, without AI, maybe we cannot do anything. But our problem was how to get, because if I define AI, it's kind of black box based on training data. But in the ship side, in our project, actually it was very difficult to get a considerable, reliable training data is problem. So it's the only way for math, but we don't have yet how to evaluate the AI system. That's the important part to the future work, I think. Thank you.
I think I will try to follow a bit up on what seems to be a different approach from the United States and EU, in EU being a bit more conservative. Øyvind, what do you think about Norway? We are not members of EU, but we have adopted the EU Act. What is the general... do we have to be a bit afraid of AI, or is we fully embracing it?
No, I think we are pretty good at embracing it, and it's being pushed into many applications. But at the same time, I think the EU Act is wise in terms of being mindful about also the potential negative consequences of AI. So it's a balancing act, right, to exploit the positive sides and avoid the downsides. And I think that's if we allow private actors to go completely haywire with the public data and personal data to develop services for their own profits, the way we see some of the big companies doing, I don't think it's good for the public good. So you can say it's hindering innovation, but I'm not sure if that innovation is that good, the one we're hindering. And as long as we can make sure that we have, have the data and means available to develop the useful AI, then I'm not too concerned about the AI Act.
No. And Ando, do you have any, what is the feeling in Japan? Should it be regulated or should it be embraced as the big innovating?
Yeah, I think Japanese tendency is rather, not protective, but rather, actually, probably the level of the people's concerns about AI is probably lower than others. That's my feeling. For instance, we from a childhood, we are seeing we have been seeing a lot of cartoons like robots and but so many like robots support our daily living. That is actually we are feeling like this. The technology is not that bad thing, but rather a good thing to cooperate. Probably that is kind of like a mentality of us.
And Korea, Ian Kim, do you?
You mean general use of AI in Korea?
Or kind of the public perception?
Yeah, maybe actually Korean students actually use ChatGPT a lot in every homeworks, and also the Koreans are very familiar with the kind of cleaning robots like that. All system is that robot is AI, so quite popular in Korea, but in our side, in the math or ship shipping companies still doesn't believe. So we must do something more to, certify the shipping company peoples. That's my opinion about that.
So if you go directly to the shipping sector, it's the same in Japan?
Yeah, of course. I talked about like kids and robots and cartoon things, but of course it's about the best ship operator, and I'm from a shipping company. And then, of course, we are quite conservative, of course. And then, of course, safety first, and then also, no incident is actually basically accepted. Then actually, we have to be very, very strict about those the technology subjects. But at the same time, now actually, even already not autonomous, but the autopilot, and then like a cargo control system, and then many already control system on board. And so already crews, captains, chief engineers, they are dealing with a lot of software and a lot of control system. But still, if some incident happens, of course, all the responsibility is actually belong to basically ship owner side. So actually, in that sense, actually already. Captains, the crews are accepting some level of such a risk of technology and so on. So, in that sense, actually, there are not that big changes if we consider, such autonomous technology as far as humans on board or humans in the loop.
Yeah, Sean, you.
Yeah, thanks. Just to build on that, actually, that's what I was thinking from the U.S. perspective, is really this focus on risk, but also liability. In terms of how serious is the U.S. taking it in terms of regulations, at last count, I think we had over 1,000 pieces of legislation proposed at the state level. So that's just at the state level, and then at the federal level, of course, they're looking to make sure that areas of AI that the federal government should control are essentially in place, so that again they can preempt the states from passing bills that would essentially restrict the development of AI. The bigger picture again is that it's part of a national security issue. Those that have been following U.S. news probably won't be surprised to hear that. So a lot of what we're seeing in terms of policy initiatives, whether it's AI or trade, are generally related to national security, national defense, and then countering other countries like China, making sure that the U.S. is ahead. And this is a fear that is driving a lot of these developments of legal frameworks.
So if we continue in the maritime sector, do you have any opinions of where AI is mostly deployed, or the areas where AI can be utilized best? Any points? I'm not sure if you want to answer, but...
Yeah. From the U.S., we're seeing, we do work with clients in this space. We are seeing it again. We are seeing defense applications. That's probably the most, and this has always been the case. I think this is the third North shipment I've spoken at, and it continues to be the leading sector for this type of technology, which is common in the United States. We see it mostly on the defense side first, and then later commercial applications. We are seeing, I would say it's not quite all the way to using full artificial intelligence, but it's more of advanced autonomy. But I think that if you speak to people in the defense sector, they are aggressively pursuing the applications on the defense side. The other consideration, we talked about risk and liability. The other is ethical concerns, and that is really, Congress has concerns about that, making sure that we have control of this. I think somebody else touched on this, is making sure that the AI doesn't get too far ahead of what we can control, that it then becomes detrimental to us.
Yeah. Jakob?
Thank you. I'll start with your first question on the development and the EU AI Act, perhaps before going into applications. And I should say, it's not the AI Act is not a maritime act is horizontal for any AI use in any sector, in any area, what we call horizontal legislation. But you have always to come back to the dilemma that we are facing as regulators. If we do not do, we are accused of leaving market going wild. I agree. And if we do, we are accused of stifling that market in its ambition. So it's a balance between those two all the time, and it's not easy to find that balance. And by the way, it's not Commission doing this, it is decided by all the member states and the European Parliament, just to recall that because it's very often missed. So it is a common effort that everybody has agreed to, where the Commission has made a proposal. What is the EU AI Act? I dare say it's not intended to make things more difficult. I think, summarizing it, it's probably intended to put things in an orderly framework. I think it has an aim to ensure that whatever we develop, it's safe, and a key word for us, it's transparent, and also that it reflects fundamental rights. Integrity, and maybe another part. It's very high on the agenda in Europe. Data protection, very high. Again, not an obstacle, something to adhere to, but it's a great concern. Again, it's not from the Commission, it's from the citizens. The goal is to foster the use of AI in a manner that maximizes benefits while minimizing risk. And I think that is the summary, in an orderly manner. It may be seen initially as a bit of bureaucracy, but I think it's inevitable when you're entering new areas where we don't really know perhaps exactly where it is leading, that you need both the trial and test, the errors, you need to document it, you need to have a little bit of assessment of that, you need to risk assessment for seeing where are the boundaries, and you have to learn as you go along. I liked very much the morning sessions, and for me there was one conclusion in this. We are landing on our feet, we are taking a stepwise approach, and we are learning for each step. And I think that sort of fits in this concept. So surely I've heard it as well. Why is maritime even concerned? Well, you can say maybe they are not, but we don't know for sure because we don't know all the applications or the autonomy we might see in the future. And that's why it is a horizontal legislation. Coming quickly into your other question on where we can see this, naturally you are very much ship-centric here. How can it help on board, or you automate functions and you may be more efficient and so on. And I think that is very good, and that's what I meant when I said when we can use this, whatever we call it, to help those in charge, being on the bridge or in a remote control center, then and we achieve the same or hopefully even higher levels of safety, resilience, etc., then it's a good thing. But we forget the land side sometimes, and I just want to flag that a little bit. How can we use AI from a VTS point of view? Vessel traffic services and monitoring, maritime surveillance point of view. And we have had this theme in this conference many times. We are not going to replace the commercial vessels with very quickly with vessels that are all remote controlled or high levels of automation. They're going to have different levels of automation, but we're going to have a bit of mixed traffic. So we're going to have to think from the land perspective on this as well. We're also going to have to think about administrations. This is not nuts and bolts any longer and going on board and surveying. So that comes back to who does what in the responsibility here. At the end of the day, I guess, such a ship, because Mars is not a ship type, will have a certification. Or unless she's only domestic, she will still need certification, but she can't sail outside. But still, that's the trust. So somewhere we will have to have a broader common understanding of these things. Thank you.
Yep. We'll come back to that in the next session, actually. But Even in the maritime sector, where is the most promising applications?
Yeah, where are the most promising applications? I touched a little bit upon it in my introduction here, but I follow your point, Jakob. But we need to look at the whole industry, not just what's happening on board the vessels. And of course, I think the most prominent application today is still in analytics. So the IoT, big data hype we had a few years back when everyone thought they could get gold from all the data. Well, it's starting to turn real now. We're getting control of data quality, data provenance, and getting useful applications from that. So I think maybe that's where we see the broadest applications today. And I'm sure there are many processes around maritime operations that I'm not that deeply into, where this will be applicable. When it comes to the onboard usage, which is closer to my field, I very much support again the conclusions from this morning about the stepwise approach. I mean, we're not going straight into uncrewed operation, and we need to think about these systems as supporting the crew and making a transition of tasks and responsibilities from onboard crew to the onboard systems and to supporting crew at an ROC. So, of course, this complicates the distribution of tasks and responsibilities and liability between more agents. So to say, you have onboard people, you have the machines on board, and you have people remote. But that transition is happening step by step. And what's important, in my opinion, here is transparency. I think you touched upon that as well. I have no faith in the big black box machine learning systems. The approach that Tesla has been taking for their autopilot, where you basically feed loads of sensor data into a big black box and you get the steering wheel and accelerator output. It might be possible to do in the automotive industry with the kind of scale that a company like Tesla has. But they've also realized they're not getting enough data from their real cars. They need to do massive simulations to generate synthetic data to train their systems. And of course, in the maritime industry, as you pointed out, we don't have those data sets. So to me, it's just not a viable solution. And also, it's a challenge that if you train your data, train your system with data from a specific area, with a specific type of traffic for a specific vessel, that navigation system, which is data-driven, you won't be able to transfer that to another vessel type or to a new location, because it's all kind of constrained by the exact data it's been trained on. So I very much believe in a much more modular and structured approach, where yes, you need training data for specific parts of that application, like for example machine vision. So again, looking at applications today, the most prominent use of onboard AI today is in machine vision systems for decision support. Right? And with the most prominent component now being Orca AI, they have really started to scale this. Very impressive what they're doing, and they are using advanced machine vision algorithms to provide decision support for the crew on board. So I think that's, but of course, that's still not autonomy. It is decision support, and taking the steps from that information to actually closing the loop and controlling the vessel that's a big step. So and to do that, you need quite a lot of more building blocks, right? And which is what we are really focusing on in my company, in Zebus, which is to build the sensor fusion and target tracking capabilities to understand the surroundings, to build the navigation planning algorithms and the motion control algorithms, but do it in a structured way, so it can be analyzed and assured separately. So that's I think we need to do it a stepwise approach, and think carefully about our architecture and design.
Yep. And I think also this applies, at least my understanding from what's going on in Japan, it's very much focused on decision support, perhaps more than pure autonomy, or am I wrong?
Actually, yeah, nowadays, yes, we are actually very much focusing on this, like a collision avoidance type of thing. That is right. But actually, when we started, actually, 2016, actually, we are rather focused on the situational awareness part. Because in Japan, actually, I mean, and also, I mean, personally, I have some research background about like human factors, and then that time actually, I mean, the proper situational awareness. I mean, the cause of the human, I mean, the incidents are caused by not by the mistake in decision making, but rather in something. I mean, the mistake in the situational awareness. So by complement or support situational awareness, we could reduce such incidents, actions at all. That was actually the initial start in 2016. And also, luckily, actually, in Japan, like we have good navigation equipment manufacturers such as like Furuno and Japan Radio Communication. They are providing like radars and ARPAs and so on. So then, on top of that, probably we can enhance such situational support. But then. So I think that is actually good. It seems that component, I mean, works well. But to develop the full autonomous function, then of course we need a proper decision making and also proper action module necessary. Then actually we started decision making part, and then actually we realized that I'm coming from NYK, and we have somehow from like last 30-40 years actually. The captains who have marine experience have running research about like a collision avoidance type of thing. Then actually, when we see all those like achievement, probably that actually, I mean, not by technicians like me, but like a captains themselves probably produce nice collision avoidance system. That is, and so it's kind of like they are transferring their way of thinking into machines. That is actually, we already had some prototype. So actually when we were asked to develop such a fully autonomous function, then actually we transfer that existing decision-making function into the actual collision avoidance algorithm. So that actually went well in our demonstration. So, but originally we started from situational awareness.
I think actually it may be the same captain I heard giving a talk in Korea a couple of weeks ago. And the point the captain tried to make, or made actually very good, is that the main purpose of anti-collision is to avoid problems. Not solve problems if you get into it. Avoid the problems. And that's a very interesting point. Inkin, Korea.
Actually, in the industry side, the Korean three big shipbuilders, they are making commercial kind of systems to decision supporting systems. So, I remember Hyundai's Hainas, something like that. I believe they don't tell a detail, but I guess they are using some AI algorithms to situation awareness, because they are using not just AIS, but also visions and radar data, I think. But in my experience in CAS project, Korean national project, AI is mainly used in situation awareness and also condition-based management system for main engines and machinery parts, something like that. But on the other side, AI is not used in control system for navigation and speed, because the training data is not easy to obtain in that case, but also it's not easy to define. That's the reason why I don't know, other countries are already using AI in control navigation and engines. But anyway, in Korea, we didn't use AI in control systems. Anyway, the situation awareness, AI is outstanding for the detection, for especially real-time sensor fusions like that. The most important thing is how to collect the training data in this case too. So at first stage, our situation awareness research team sails with a small boat many times to get a real-time AIS and LiDAR and LiDAR, something like that. And after that, we build a 25-meter class test ship. So with that ship, also we do a lot of sail for only gathering data. And after that, right now, that situation awareness system is equipped 1800 TEU container ship, which sails from Korea and China and Vietnam. So it's a round trip. But we are still making data. That's the problem. But another, for CBM, condition-based maintenance, we need some kind of out-of-order signal. So in our case, we used real main engines in land and the piping systems. And we make intentional trouble in the main engines and pipings and generators, etc. So we can get some kind of out-of-order signal, but it's not good enough because we also need sailing data of main engines. So we did already 5-year project, but we are still working on gathering the data right now. But anyway, it works. It looks like it works very well, especially for situation awareness. We simulated with that system in simulation-based. It takes a very complex situation. We can avoid everything, but we still need to should make more effort to gathering data. But this data is not, right now, we are not open to each other. That's another point we should, in the near future, because in order to sail from some port to port, the other country's port, we don't have the information. But that port information, especially for training data, is maybe cannot provide. So that's the problem to AI, maritime sector. AI is going to, commercial, I think.
Thank you. I think that's interesting points. And if I should conclude so far, I think most of you agree that we have to be careful with it, and lack of data is a special consideration. Sean?
Yeah, just a bit more on the U.S. perspective on that. I think that the U.S., their comfort zone right now is on the navigation support side, so not necessarily turning it over to the AI for all decision making. But one thing we hadn't touched on that we're really focused on in the United States, so the sustainability side of this, which is not a term that we use in the U.S. anymore, at least for the next 3.5 years or so. But I can say it here. But it's the same concept. So for those that don't know, to develop generative AI takes an enormous amount of energy. And that is something that, just to touch on that side of the session here, the sustainable way to develop that energy, we're seeing it in the United States, projects being proposed the size of small cities just to power it. So we're seeing right now when it comes to alternative energy, nuclear right now is at the top of the list because of the power needs for that. in a country like Norway, where there's enormous use of wind and hydropower, I think that's something where we could see more crossover use. So whether it's things like hydropower, wave energy, things like that, but then also maybe barges that are nuclear barges that can also be used to have that crossover with maritime to land-based use. But that's just something I wanted to make sure people are aware of. It's not just sitting down at the computer console and creating generative AI. It requires an enormous amount of power. We in the United States are struggling with this because of our electrical grid that is outdated and cannot even support the off and on growing offshore wind that's meant to power cities. So that's just something I'm not sure if you're seeing that also in Europe, Japan, or Korea or Norway, but we are seeing this in the United States of thinking ahead to build these giant power plants just for AI.
Yeah. It's a bit outside of the, but we have actually the problem in Norway. We had a recent discussion where the power should be sent to a computer farm or to a production industry because there was limited capacity in the network. I think another thing that kind of this lack of training data and also lack of performance standards raises is, do we need more international cooperation in the development of common standards, common data sets, training sets, stuff like that? Or is this mainly a national competitive edge? So if somebody wants to start, Jakob?
Holding the microphone, yes. I think this is a key question. I think in my mind, no doubt, everybody has to open up. And if we are, as we are saying, that AI needs more data than ever before, and we are not opening up, I like the expression sheet in, sheet out, then that's what we will get. And then how is that purposeful? So I hear many saying, yes, we have a fantastic product, but we are not going to share any of the data we have because that's our competitive advantage. And that is fair enough, and that is the classical thinking. Only you may then get an approval for that product, for that ship, in your national waters, and that's it, because nobody else has no idea what this is about. And then you are actually shooting yourself in the foot, in my view. So I am here coming back to the morning session a little bit, where we came into this that is going to come once we have the non-mandatory code of an experience building phase. And we have to hammer out the details of how we're going to do that. But from my perspective, training data, sharing data from all who are involved in trials and tests for whatever, we're going to have to hammer out that there is an orderly way to share such data for the benefit of all, for developing this. If we keep talking and want it international, then we have to bring that back into that field as well. And that's my take on that. Thank you.
Yeah, I think that's a utopia. And I think it's not really just a national interest, but I think it's individual company interest. And I think battling that is going to be extremely hard. So if you want that kind of development, you actually need to put in the public resources to gather public data sets that are shared openly. I don't think anyone can expect private companies to share all their data with competition. That just won't happen. I mean, that would be irresponsible of me towards my owners if I share all my data. So with that being said, I don't follow the need for these huge data sets, because you don't need that to develop trustworthy autonomy. And that's really the point I want to come back to, is that trying to train a kind of big machine learning system on huge data sets, it's not scalable and it's not going to work. I mean, it's for very narrow application, okay. But if you want to do this for a vessel or a system that should be able to operate different kinds of vessels in different ports, in different regions, different traffic situations, it's not the way to go. So, I mean, we have a very clear strategy in ZBus, and which I'm, by the way, also teaching to my students at university, and it's a modular approach, right? Which means that we are, instead of doing a big black box system, we are using isolated training data for different parts of the system. And actually, for our part, it's mainly on the machine vision side. And I could take a machine vision algorithm from another provider and simply integrate that into my autonomy system. So I think this perception that we need these huge data sets to succeed with autonomous ships, to me, is a false perception. And if we hunt for that, we will never get to our desired kind of end state. So I think other ways of structuring the autonomy systems is the way to go. On the other hand, I believe that we have a very important job to do on the assurance side. But then we're dovetailing into the next discussion. But just to give a kind of quick reflection on that. I worked in DNV before I started ZBus, worked with something called digital assurance, and I was researching exactly how to build trust in complex software-driven systems. And in that case, having common data sets that give performance expectations, right? That you have scenarios and acceptance criteria that are being used in the assurance process. That makes a lot of sense, right? Because that would set the benchmark. It sets a level that everyone needs to pass in order to get their systems certified for operation. So I would rather focus attention on that side, let the individual companies work on their solutions to solve the problem, and put efforts into how are we going to build the proper assurance regime for those systems.
And that actually, it points a bit back to the previous session where we had Siv from NES, which also had the same argument that you have to build the system modular. And I talked to her afterwards, and she had a very good point that if you want to sell these systems, they have to be kind of understandable and avoid this vendor lock-in that you get with these huge monolithic solutions. So there's quite a wide range of arguments. So other comments to this point?
Yeah, just from the U.S. perspective, I think that the U.S. has been involved in various sectors internationally with trying to establish whether it's codes of conduct, various frameworks. I'm not sure what an international standard would look like. The U.S. primarily is focused on governance and control. The U.S. is less concerned with individual privacy compared to Europe or transparency. We've, for almost a decade, talked about the sharing of information and the difference between the U.S. and Europe, and U.S. Commercial companies just very reluctant to engage in sharing of information, just a different commercial philosophy, and also just lack of trust with the U.S. government. If they use a U.S. government platform to share the information, who actually has control of that? And I think we're seeing that in the past few months, that fear is beyond just AI, but who has access to what information? But we just don't have the same protections, the same focus in our legal practice. Whenever GDPR comes up, it seems to be a four-letter word, and scares lawyers into figuring out how we actually deal with it from the U.S. perspective. I think that what the U.S. is focused on is a level playing field when it comes to an international approach. Again, it's meant for control of the technology, but that's what I'm seeing. The other issue that's difficult to control from the international perspective is liability. So liability for the developer, liability for the user. This is in the United States and amongst other countries around the world, dealt with differently, whether it's at the state level in the United States, whether it's at the country level in Europe. That is a focus of the United States. So how an international regime would deal with liability, I think it's very challenging. So it may be something like a starting with voluntary codes of conduct, moving towards some type of international convention that's maybe aspirational in nature. Not sure what that looks like, but I do know that we have several different U.S. sectors that do engage around the world with this.
And I think liability also will come up in the next session. Ando? Or?
Okay. Well, let me comment. I basically align with what we've been said and Sean mentioned. I'm also rather negative to, the share data, because as a private company, because we already invest to collect the data and so on, and how we can cover that investment, then actually we cannot just share the data. So in that sense, actually, I agree with Oibin that. International cooperation or collaboration is definitely necessary, because this the ship actually, for instance, if you consider a number of the vessels, actually this global marine, there are about 100,000 vessels or something. If I compare to other automotive and then actually far less number. Then actually, but still, we need a good appropriate level of maturity of technology. Then, without such mass production, and even each single vessel have different design and so on. So then, actually, our challenge is how we effectively train AI with a limited number of vessels, and then, but at the same time, pursue maturity. So that is, I think, cost effectively. Otherwise, actually, in the end, the product is very expensive, and we are not afford to buy. So in that sense, actually, one approach is I've been mentioned, the white box module-based approaches, and then we can already we have radar equities and already function qualified, and already such standardized equipment there. And on top of that, if we can define properly a navigational autonomous navigation system, the function blocks are properly defined, then probably we can then what are the interface in between those function blocks, that kind of an interface, and if then company A and company B can communicate by such a standardized protocol, those area definitely there are the area to collaborate internationally. That's my sense.
The balance between national competition or cooperation is very complex, I think. If I say we need competition, in that case, maybe many countries pursue economic leaderships. So maybe many countries foresee mass as a path of to dominate future maritime trade and innovation, I think. That's the problem. But the strategic autonomy is defense. It's another story. But while technology is national, ship across international waters anyway. So we should tilting toward cooperation. But if maritime transport is international, so without harmonized AI and mass regulation with cooperation, we risk legal conflicts in territorial waters, and also some denying port entry or insurance and liability confusions like that. And also safety, and the point of safety and interoperability. Autonomous ships must safely interact with human piloted ships for many countries. That's another part we should pursue to cooperate. And common AI behavior standards are essential. Yeah. So to prevent accident. And also another point for cooperation is cybersecurity. Yeah, AI system on ships are potential target for attacks. So international cooperation is needed for that kind of threat intelligence, I think. So in order to do that, IMO is very important. I think many countries are still feeling competitions, but IMO should handle something to cooperate point, especially for in the mass code. So far, mass code doesn't define how to evaluate AI systems. But maybe just mentioned like a goal-based approach, something like that, because it's too much general. I think in experience building phase right now, so in this period, we should cooperate to IMO can make some kind of how to evaluate the AI. That's the another big point for cooperation, I think.
Thank you. We have a few minutes left, so yes, please. No, I can get you the microphone. Oh. We step down.
Yeah, hi, my name is Eirin Fossberg. I'm the CEO and co-founder of NAA Development, and we work with training data specifically for computer vision. And I really appreciate all your perspectives, and I think it's important to highlight that when you're working with AI and data, and when you say that there's a lack of training data, you can put up a camera anywhere and you'll get the data. The actual issue here is that the data preparation phase takes up to 80% of AI developer time. And so this becomes a workforce problem. And that is very interesting to see this international perspective and collaborations between countries. So I wonder if you have any perspectives on how to deal with supervised training across borders.
We have to have that back. Sorry.
Thank you. Yeah. I think the supervised training is, for instance, let's say, okay, like a computer vision system you mentioned, then actually somebody or a computer or somebody anyhow assigned annotations on the data in the image. Okay, this is a bezel. This is something that should be avoided. So it also costs not only collecting the data, but also such annotating such information is also very much costly. So then, and of course, so without such like a supervised training data, actually computer vision system cannot work. So then, but still, it's very, very costly. So including that kind of annotation data. Again, like Øyvind mentioned, like it is a data set for testing functions as part of like a standard. Then that is actually we can share the same data. Then we can evaluate the performance of each such functionality of computer vision system. But to train the data is again it's very, very costly. So that is probably private company who are doing competing. Probably they will not share. That's my comment.
Hello, I'm Sis Papayoyo from the Norwegian Maritime Authority. I would like perhaps a comment without wanting to put you, Jakob, on the spotlight, but there is the EU Data Act that is soon coming into force in the EU, and that is supposed to force manufacturers to share more data with administrations. So that's one part, and I'm asking also from a point of ignorance. We don't know how this will influence us. But the other thing that I wanted to comment is that, at least for us as an administration, I had the impression that you and Øyvind were talking about different kinds of data, in a sense. For us as an administration, the data that we would like to get is not really, it is aggregated data. We obviously cannot deal with the amounts of data that you have in commercial operations or in developing your products. At the same time, for us, it is important that transparency so that we can understand better how the systems work, how they are being certified, etc. So I would really love your comment on that. Thank you.
Sure. I could start. But yeah, I think those are different kinds of data, as you say. So I think the main discussion here now has been on the AI training data, which is different from what you would want to have. I mean, if you were to be swarmed by training data from perception data from all different suppliers, you would have a crazy data center and not being able to to make any sense of it. So yeah, I mean, if legislation is passed that requires sharing aggregated data, I think that's fine. And it's also a big difference between sharing that with the authorities and sharing it openly with all your competitors. So I'm not concerned really about that perspective.
Thank you, thank you, Sifis, for very targeted question. You call it comment? Yes. No. I underline transparency because that's one of the parts in the AI Act. I have not qualified the aggregated or detailed data in this. Depends on what you are looking at. And as I said before, we don't know that for many things as yet. There are business ideas. I'm certainly not saying that everything is public for everybody. That was not my point. I'm not backtracking. I'm saying it needs to be transparent enough to understand if the algorithm does what it says. How can you evaluate that? So this is the. I may be confused, and I admit that. Nothing unusual, but this is where it comes down to. I will take the opportunity, Ørnulf, if you bear with me, to quote some lines, and we'll see if you recognize this. This is from a speech. There is also a longer-term existential threat that will arise when we create digital beings that are more intelligent than ourselves. We have no idea whether we can stay in control. But we now have evidence that if they are created by companies motivated by short-term profits, our safety will not be the top priority. We urgently need research on how to prevent these beings from wanting to take control. They are no longer science fiction. This is from Professor Geoffrey Hinton at his speech at the Nobel Prize giving, having just won the Nobel Prize. And it was, of course, highlighted a lot in media because he's one of the fathers or claimed fathers of AI. And I'm just having that in mind for all of this, and that I think is the frame for the AI Act, that there is a certain need for controlled conditions here. And for maritime, that's nothing new. Everything that goes on board has been tried and tested and verified before it's being put on board, certainly if it is safety critical. So having just seen Mission Impossible with my two sons this weekend, I hope we are not getting into the Mission Impossible. Thank you.
Okay, I think we'll stop there. I think, in a sense, my impression from what the panel has said is that they are quite aligned with what we said in panel 1. You have to be careful, step by step, keep the human in the loop, and so on and so forth. And I think that none is expecting this general artificial intelligence to occur and throw us out of our offices anytime soon. But still, there are issues with AI, which we have pointed to. And I think the next session will go a bit more in detail in different problems. Now is, again, time for coffee and other refreshments outside. And we will continue at 15:30, according to my notes. So thank you very much to the panel.
Okay, here I am again. And welcome back now to the last session for this summit. And we will address the evolving role of the human operator. for me, that's a very interesting topic, just as the last session that we had about AI, that for me at least gave a better understanding for what AI is and is not, and also that it can be a little bit dangerous and scary if we don't do this right. We need to do it carefully, using a step-by-step approach as mentioned, ensuring a proper legal framework for it, and keep the human in the loop for control. Yes. And we are also just in the start of AI, so that's going to be very interesting to follow in the future. Now, the last two Slido questions before I turn the floor over to Barbara Seller, who will be the moderator for our last session. So if you have your telephones, we will start, and I will give you a few seconds on each of the questions. This one, would you go on board and sail with a fully unmanned ferry? So let's see if our speakers have scared you or if you are more confident. I think they have done a good job, the speakers. Okay, then we could go over to the last and final question. Would you be prepared to pay a slightly higher transport cost if it would mean 0 accidents, 0 waste, 0 emissions? Ooh, okay, good start. But as you see, money always counts. What's left in your pocket by the end of the day. Okay. That was it. That was for me. And now I give the floor to Barbara, and she will continue this last session. Thank you.
Okay. So, thank you so much. There's still a lot of people in the room, so that's great. So my name is Barbara Sellier. I'm the head of unit for maritime safety in the European Commission. And I'm super happy to be here in person. It's for this 7th, MAS Summit. I have followed the discussions online beforehand, but it's my first time in person. I must say it's one of my favorite files. It's really a file that is at the crossroads of everything we're doing, be it safety, of course, but also reduction of emissions, greenhouse gas emissions from ships, security, seafarers, yes, digitalization, obviously. So it's really, and competitiveness now, yes, indeed, and the industrial strategy you heard from Fotini this morning. Alors, this is the last panel, and I'm going to invite our panelists without further ado. Let me see. I'm going to make sure that I pronounce their name properly. And I will start first with calling on stage John McDermott, who is currently chair of safety at the University of York. Then Tor Stokke, very good, who is a partner in the law, okay, you will really need to apologize me, with the law firm Simonson Votvik. Okay. Then next to come is Sveinung Sommer, who is the CEO of Remota. Then I'm calling Erik Rødseth, professor at the Faculty of Law at the University of Oslo. And finally, Frank Borg Pedersen, Maritime Program Director in DNV Group Research and Development Unit. So, okay, I'll very soon give you the floor, of course. Just to say, this session is about the challenges, the problems. We've heard already in the previous panel a number of issues. Let's try still to make it a positive panel so that we can finish the day on a positive note. Before we go into the substance, I very much liked what happened in the second panel, I think, where the moderator asked each of the panelists to say a few words about yourself so that we know, yes, how your background is relevant and most importantly, what kind of work you are doing on autonomous shipping and more specifically artificial intelligence. And I will come and sit down to be with you. So we can start in this order with you, John. Ah, yes, the microphone, of course. Okay. Voilà. No. Alors, here you are. I think, okay, it's on.
Thank you. So I've worked on safety of software-intensive systems for about 40 years. The first one I worked on had 5,000 lines of code in it. They've got a tad more complicated over the years. 7 years ago, we got funding from the Knowledge Register Foundation, charity of a Knowledge Register group, to study assurance of autonomous systems, including AI. So we've worked in maybe a dozen different domains over that period of time, building up assurance frameworks. In the last 2 years or so, we've had a lot of focus on maritime and have some projects in Europe, in the Americas, and in Asia as well, which I can say something about if appropriate. Thanks.
Thank you. My name is Tor Stokke, and I'm a partner with the Simonsen Vogt Vik, which in English can be troublesome to say. And I work with the technology department of our firm, both in terms of procuring IT solutions directly and when you apply them into other products, such as helicopters. I used to say that it's not the airframe that's the problematic thing, it's the software aboard vessels and autonomous aircrafts. In all cases, AI is coming into the debate and the contracts and is for the legal profession a God's gift to us. We'll come back to why.
Good afternoon. My name is Sveinung Suma. I'm the CEO at Remota. It's a pleasure to be here at the latest panel debate, trying to keep you all awake. By background, I'm a humble hydrodynamics engineer, so no heavy kind of education within AI. But more importantly, I represent Remota. We basically provide a remote control to our customers, having technology on board our customers' vessels to interface with functions that then can be remotely operated from the ROC remote operating centers that we build for our clients and keep that service 24/7 up and running for the customers. And within here today, I think my key message is kind of the focus on the operator when we talk about all of this technology and where we're going. So the focus on the operator and the operator capability is kind of my focus.
Hi, I'm Erik Krosag. I'm a lawyer, and even worse, an academic lawyer. And I have been working with maritime law for a number of years. And in the recent years, I've been very interested in autonomous vessels. And I was the co-editor of one of the co-editors of a book called Autonomous Vessels and the Law, which is highly recommended.
Yeah, good afternoon. My name is Frank Børre Pedersen from DNV. I'm the Maritime Research Director, and maybe I should start by saying that this is a position that Øyvind Smogli had when he left for Cebus. So a lot of the things that Øyvind said, you will hear again from me, but slightly with a different twist. Because what we do is really not to develop AI as such, but to help customers assure it. And then, of course, we use AI to do that. And I will speak more about that later.
Okay, super. Thanks a lot for that. Okay, to start the panel, I think I would like to hear from the operator perspective, and if you can raise the challenges for safety of the use of AI in more details and maybe in a more concrete way than we heard before today. Yeah.
Thank you. So, kind of thinking, you know, what's happening now. It's we're seeing, at least we believe so. I believe in a quite major change in how we operate vessels, and with that comes a lot of new technology, and new, understanding these technologies and directions they're taking, autonomy, AI. So there's a lot of tech going about, and with this kind of the same intention: safer, more effective, sustainable ways of operating in the oceans. And then kind of taking that all down and seeing it through an operator perspective. A navigator who has been trained as a navigator, maybe sailing on board vessels as a navigator now, being set in a new environment in a remote operation center. Meaning the situational awareness needs to be carefully designed. There are some kind of handicaps that you get. You have some senses that are no longer giving you the right, say, impulses that you would have on the vessel. So we really need to think about the operator perspective and how are they, say, considered in what we are giving them. So I was trying to kind of give an example of how they might perceive coming into a room with a lot of new stuff. And maybe not a good example, but the best example I could think of was, in my car, which is, I guess, 10 years old, you have your parking brake, which is a flip of a switch, and the parking brake goes on. But if you're driving at 80 kilometers per hour and you use that switch, have you tried that? Anyone who tried that, do you know what it does?
No.
So that comes into, and of course in newer cars you have a lot of other kind of, you have the entertainment system, you have the cruise control with many kind of features to it. But it gives kind of that perspective to it that it's complex. And of course a navigator needs to be trained in using what he is about to use. But at the same time, as drivers, we are trained to drive the car. But there's a lot of functions that we might not be aware of. So kind of to kind of go from the tech perspective, the legal perspective, to the operator and how to operate, and knowing that when I push this button, I expect something to happen. And what is that? So if we're looking at AI, and if I'm a navigator and I'm relying on AI, I think I need to rely on AI as I would to my fellow colleague on the bridge, the mate. So if he is doing something, I know he has the training, I know what kind of condition he is in, I know that he is vigilant of his surroundings, but I don't know what AI is doing. So kind of that's my first topic I would like to discuss, and is how we know that the quality of the AI decision or the advice AI is given, how can I trust that? And the second one is, okay, if something goes wrong, responsibility, liability, if I'm still the captain on the vessel, so that kind of also ties into I need to trust the system, and if I'm going to be responsible, I need to know kind of the liabilities and the law around that. So that's kind of my opening on this. Yeah.
Mm-hmm. Okay, thanks a lot. Now I would like to turn to Frank. I think you said that indeed you had also some use cases that you could explain before. But just to stay for the time being on the use case.
Yes, I mean AI is very complex, and since we are supposed to assure AI made by others, we have to get our hands dirty. So 10 years ago in the research department of DNV, we started to develop AI. And then we were looking for use cases close to home. What are we doing in the sharp end where we could deploy AI and see how that impacts the work process, our surveyors, etc. So basically we're saying we are sending out surveyors all around the world that go into tanks that's dangerous, it's expensive, it's dark and dirty. And how could we use AI with computer visions mounted on drones that would fly inside of the tank and help the surveyor, not replace the surveyor, but help them. They could take hours and hours of video, and then the AI would go through and identify hotspots, potential deformation, cracks, corrosions, etc., and then maybe do a close-up, or maybe call on the surveyor to actually make a close-up. So then we saw that we could re-engineer the working process of the surveyor with the help of AI. And I think for us, that was important. We failed a lot. We saw, depending on the lighting in the tank, how we had trained the algorithms, if you rotate the image slightly, or if you have some distortion on the image, the algorithm could potentially fail. So, I mean, we experienced all the kind of failures, or many failures at least, that you could have, and I think that was very important for us. And then we realized that, much like Øyvind Smogli said about modularity, AI is just a module. So if you have a safe system or a safe process, you could live with a module that is, acceptable, but not high integrity. But then you need to have a system that accounts for that. So that was kind of our learning and what we have later built into our class guidelines as well.
Okay, thanks a lot. Any reaction so far to these interventions from other speakers, other panelists?
Make some comments about assurance if you...
Sorry.
Yeah, because otherwise I was also going to turn to the regulatory aspects, but please go ahead.
Of course. So I think the important thing underlying this is actually how we get enough assurance in the algorithms to be able to deploy them. And there are some standards in this space, although not for maritime, but there's some evolving frameworks that we and others have worked on, saying about the sort of evidence you need to build confidence in the algorithm. So I think those are well structured. They lead you to what's called an assurance case, which would actually fit in well with goal-based approaches, the IMO mass code. I think there's a number of things that we know, like the structure of those, sort of evidence you want. What I think we have yet to establish is what depth of evidence, how much you need. It's certainly not the whole training data set. It would be worthless to a regulator, assurer. It's too complex, and you can't make sense of it without actually having the algorithms that are being deployed. So I think one of the things we need to do as a community is work out what's a sensible level of evidence to provide to enable regulators to make confident decisions that things are safe to deploy, to allow insurers to write insurance policies, and so on. And one other observation I would make is this really needs to address the whole maritime autonomy infrastructure. The vessels are very important. Those are what move, what can cause damage, but the remote operating centers, the communications networks, the way we maintain them, all matter, and we need to focus on the glamorous things like navigation, but also worry about how we manage the machinery and the equipment on the vessel. So it's a very broad problem. We've got some good starting points, but there's a lot more to do that needs this sort of international collaboration.
Okay, thanks a lot. Yes, so I think now it's time to turn to the difficult question about the regulatory environment. So who wants to start in terms of, yes, where are we, what is needed, what are the challenges, have we gone already too far, what about this, is this a goal-based approach, deterministic? Yes, so who wants to, yes, please go ahead.
Since I have
sorry. You have the microphone.
I have the microphone.
Go. No problem.
I'll just start. It's a legal principle that possession is half the victory.
Yes.
From the overall perspective, we have now internationally 3 major blocks of regulations. We have the European Union, we have China, and we have the US. And from a 1,000-meter perspective, they have chosen approaches that is pretty much what you would have suspected if you made a hypothesis of how they would do it. The European Union starts with values and innovation, but values are very important as a driving force. A top-down approach. The US starts the opposite way. They start with a market-based approach, decentralized, and the Chinese, they try to take the best of both worlds. A centralized approach top-down, a framework, and then, if I understand this correctly, a relatively lax follow-up of the regulations until you get big enough. So this is the overall picture, and in the difference between AI and other software, AI is software. It's used in vessels, but it's software. The difference between what we have experienced before is, of course, that AI is considered by nations as fundamental for their commercial prosperity and safety. So everything gets escalated. And we don't anymore live in the world after the Second World War, where we made ITU to make telecommunications, where we made global corporations to make satellites. It's distributed. It's a battle between nations. And by that broad picture, I will give Eric the opportunity to go into the details.
Yes, there's another legal principle that one thing is to put in the law in a nutshell, quite another thing is to keep it there. And there are many details here. And I will maintain the somewhat broad perspective by saying that the problem here is not whether the law is too strict or too relaxed. It's simply that the law is too vague. And that is a major problem for the development here. One example, which I've been working a lot with, is the collision rules. What does it mean that a vessel should yield in ample time before collision? And that's not a computer problem, because I think AI could make a very good result if we ask it to yield in ample time. But the problem is, how could we verify that this legislation is complied with? And that's impossible because it's too vague. And that's a legal problem and not an engineering problem. And so we need to sort of address a lot of these questions, and I could mention many of them later on.
I think Tor wanted to...
Just to come back to the positive side.
Yeah.
I often say that vagueness and unclarities is underestimated. It provides a framework for dealing with problems when they arise, so that the legal legislators can say that, yeah, that's what we meant. Or they can say, well, let's see what the court says. And yeah, that's what we meant. Exactly. Look at us. So I think where we are now with so much uncertainty, it's the appropriate way to take it for now, to be a little bit vague. And then we have to, by means of, as you said, the insurance sector has an important role to play. All the standardization organizations, IMO, all these attempts to get us together will roll on. And I think that the river finds its way, even if there are, even what the legislature does. But at present, I think we are at a level where we should be, and it represents 3 different ways of dealing with the regulatory issues. And sometimes you think that someone should have made an estimation of the difference in value for BNP from the US market-based approach to legislation and the European one. It should be a difference, but I think nobody knows. But I think we are at a place, it's not the best place to be, because that's how it is, but that's how we have to start.
Perhaps I could just comment things like appropriate time is the perfect specification. Engineers are innovative, are creative, and I will decide how far that is depending on the dynamics of the vessel, the channels I'm in, etc., etc. And it's perfectly reasonable then to put in an assurance case. I know the dynamics of this vessel. I know where it's operating. This is the correct time to take an appropriate maneuver. So that's the perfect specification. And next time I'm an expert witness in a court of law, I'll explain to you, why we've done this the right way. So I think that level is just spot on for the sorts of things we do. If you try to be too tight, then you'll be wrong in too many situations. So allow the freedom for the engineers to be creative and the regulators to make judgments. But you want to argue, which is excellent.
Yes, I actually strongly disagree with this, because the problem is not that the court cannot make a decision, or an expert witness, or even a human master. The problem is that the flag state authority needs to know when it can certify an autonomous vessel. And then it cannot rely on 1 or 100 expert witnesses. It cannot rely on that the court will make a decision if there is an accident after a few years. It has to know, can I certify this vessel or not? Therefore, we need more certainty.
I was going to ask Sveinung, because this is the perspective of the flag state, but also from your perspective, whether it's enough that you have this ambiguity in the regulatory framework.
I would think that the rock operator trusting the AI to not do a vague kind of action. I even talked about human-like behavior, and also, understanding, is there any, say, bias into the AI? What is it kind of, what's the reasoning behind what it's doing? If there is unclarity and say, vague frameworks, I think that might also make it more difficult for the rock operator to trust the AI system.
Could I respond shortly?
Of course.
I agree with what you're saying, but you have always to think about the alternative. How is this unvagueness going to appear? And if you look at the legal processes, both in the European Union and other places, it will not take a day or two. It's more likely that when you have completed your clarity, it's wrong. So the problem in my mind isn't that it wouldn't have been better to be unvague, but it's the lack of better alternatives. But Eric, you have a solution for that as well.
I do agree with you that it's not possible to expect the IMO or any other organization to come up with, for example, a clear definition of what is ample time. It is undesirable, I think, that they should do so, because we need to have a very flexible approach here. So what we need is a possibility for the flag state to decide whether a vessel is safe enough without defining exactly what ample time is. And if you read the UNCLOS, the Law of the Sea Convention, you will see that there are two kind of references to collision rules to keep in that example. One is a code reference to the COLREGs. That's the obligation of flag states to enforce the rules towards the master and other navigators. But then there is the other obligation of the flag state itself, and that is to avoid collisions. And if we could just clarify that, and there's unfortunately not agreement about this, but if you could clarify that the flag state's obligation at the time of certification is to make sure that the vessel does not collide, and not to define what ample time is, then we could actually get some autonomous vessels certified in our lifetime.
Okay, Franklin.
I'm not sure I want to get into this discussion, but maybe I'll stick my head out. I think it's very positive that the upcoming legislation is goal-oriented. Basically, you can say it's risk-based rather than being prescriptive. And I think that's very important in an area where you don't have strong knowledge. Only when you have strong knowledge can you really pin down and have very specific requirements. We are not there with AI at all. And probably we will not get there either, because the nature of AI is that it's very dynamic. So when we developed our RP on assurance of AI, we had the aim of listing a lot of prescriptive requirements. If you follow them, you're safe. But we failed, because that's not possible. I mean, it worked maybe on one case. So that's why we had to make it risk-based. So it's kind of reflecting the system in which this AI is used. So the identically same AI will be treated differently in two different systems. You have different kind of agency, you have different redundancies, the collision risks are different, the ecosystem is different, etc. So it's just not possible to have prescriptive requirements for the AI, at least not today. We need to gain much more knowledge. But I appreciate your statement on the ample time, which is kind of a legal thing. But I think we need to deal with this case by case, but we must deal with it. If we just sort of say this is ample time, then that's not good enough.
John.
Try to be brief to follow it up. I very much agree with Frank, and there's also a danger of trying to be too prescriptive. So if you take autonomous driving functions, we have regulations about autonomous lane keeping systems on our roads, and there's a European regulation about that. It says the driver has to be able to take over within 10 seconds of a failure of the ALKS, and that's actually written in the UNEC regulation. The evidence from experiments is it takes 20 to 40 seconds to rebuild situational awareness. So we have a very precise regulation which the manufacturers will work to, which is actually highly dangerous. Because we know that the operators can't behave that way. So as Frank says, we don't have this knowledge yet. I think there will be risks of different flag states making different decisions. I think that's why there needs to be some open collaboration on what's an appropriate level of evidence, common ways of building assurance arguments behind the mass code or similar narrower things if they're simpler vessels, and agree what level of evidence is needed. And that will vary in detail from vessel to vessel. It will also vary with location. The angle of incidence of the sun here and in Singapore is quite different. It means machine learning-based perception systems behave differently as a consequence. So you need to take that context into account. I don't know how to codify that. I don't know if anybody does, but we're much better saying you have to demonstrate that this works in the deployment context. And I think that we can do. We know how to write regulations like that now. We won't be able to make them any more precise without running the risk of actually making them dangerous unwittingly.
You were all nodding your heads, so I think, okay, so now you agree. No.
Okay, so I think looking at the risk-based approach, I think is of course the right way to do it, and step by step. So looking at say more low-risk applications of AI support systems, and then build experience, and then kind of further on the road, higher level of automation towards autonomy is of course the right way to go. And with, as I started with, all these systems, so more vessels, sensor fusion, so utilizing AI in that sense, a kind of supporting the navigator. I think that we need to go there first with low risk and then kind of advance. Yeah.
It's of course very nice to see that we build a boat as we row it, but or go along the road step by step. But if an autonomous vessel should sail, we need that to be accepted by other states. The current regulation in the IMO is that any state could refuse an autonomous vessel to enter its waters, whatever that is. And there's nothing in the development of the mass code that could really clarify, for example, this ample time question, as I use as an example. And so we need to have some clarity. And the problem is that we often think, well, then we have to define what ample time is. But the right approach would be to estimate the safety of the vessel. So the problem is not whether it complies with the cold regs, for example, but whether it's likely to collide. And we are all against collisions, so we sort of we can manage that, and we are lucky to have the EU framework, which could make the flag states operate along the same norms. And in the IMO, we would need a development of the requirements to the flag states in connection with certification of vessels.
I think, Frank.
Maybe just to build a little bit on that, Erik. I mean, we had the EU AI Act passed, and of course that was 100 pages, a very difficult document. So what did the EU do to sort of help the industry and others to start to comply with it? Well, they did something clever. They established the EU AI Pact. So the pact was a voluntary scheme where industries and stakeholders could get together, share how they interpreted the law, how they used it, what is high risk, what is low risk, and kind of flesh out all the legal uncertainties still on the table. And hopefully that can help everybody. So I think just that mechanism in itself was I think needed, and it's still very useful, I think.
Thanks. Thanks for bringing back to the artificial intelligence as well a topic. You wanted to come back?
If I may?
Yes, of course.
And yes, and the AI Act is of course not the only EU regulation in connection with artificial intelligence on board vessels. It's also the marine equipment regulation. And that's built, as far as I can see, on the good philosophy that, first of all, the IMO rules should be adhered to, but in a uniform manner within the European Union. And that means that we cannot resolve these issues in the same way for autonomous vessels as for example, autonomous cars or other AI mechanisms. We need to have some international agreement, and the IMO has not such an agreement on the agenda just now. It should have.
I've been to the IMO once, and that was a great experience for a Norwegian, because other places you are sitting back and below, but in the IMO you are in the center, at least in 1996. on the positive side again, I agree with Eric says now. So possibly there's not a disagreement, but the European Union is not the only part of the world. Even if one of the attempts by the European Union is to go first and let the others follow, like they did on the GDPR. GDPR is, I think, emboldened the European Union because they saw that by going first into this area, they could get even, I think, the Philippines have adopted the same rules as the European Union on data protection. But it is a path from the European Union to the IMO. And Eric, how do you envisage this to happen?
Yes, I've actually been quite a lot to the IMO, and I must say that the interaction between the IMO and the EU is wonderful. I mean, it's of course we all know that the EU is not a member of the IMO, and it couldn't be. But if the EU takes a few steps, the IMO will follow. And as long as you do not follow the confrontational path, I think EU could be a very, very good good pointer to the way forward here.
Thank you. Okay, let's go back to artificial intelligence. No, but it's nice to hear that. Well, it is a complicated one. I think, John, you wanted to take the floor again.
Perhaps I could take us in a slightly different direction. So we sort of got human factors in the title as well. I think it's extremely important that we look at how we build effective interactions between humans, whether they're operators in remote operating centers or maintainers and the AI-based systems. So I think it's a very important area which neither the IMO mass code nor any standards I know of really address very well. So I think that's an area which needs a lot of work. But you wanted us to be positive.
Yes.
Something I don't know how to be positive about, unfortunately, which is actually, if you look at the way AI-based systems are built, by and large, we retrain the algorithms and update them very, very frequently. So if you buy a Tesla, it's probably every 3 or 4 weeks you get an over-the-air update to the algorithm. So I think there's another real research challenge for us is actually how we work at how we do the safety assessments of AI-based systems at a cadence that allows updates that are beneficial, rather than taking the 2 years or whatever we would normally do to assess a system. So it's positive in the sense of identifying a sort of collaborative research agenda. I don't think it's constructive in the sense I don't actually know what the solution is right now. But some really important things we need to work on to enable a smooth transition to deploy this sort of technology.
Anybody want to react on this need for collaboration?
This triggered sort of my thoughts on human errors and human interaction. And first of all, I think we should get rid of the notion as soon as possible that we can create an autonomous vessel that is unfailable, or at least we know that will never fail. The best we can hope for is a vessel that is better than a human operator. And a human operator will fail from time to time. And we have to accept that. I think that's step one. And step two is, of course, we have to have some backup solution. And that's the human operator in the current thinking. And that means that we have to create AI that's at least in most cases, able to identify a situation where the limits of the system are exceeded, so that a human operator must intervene. And then, of course, the legal uncertainty arises again. How about this legal operator? What kind of responsibility does he or she have? Because the current Scandinavian maritime codes, for example, they do not envisage a navigator not on board the vessel. And if this operator is not employed by the ship owner, there could be a problem making the ship owner liable. So this is also where the law is too vague.
Just to build on that and what John said, which is really the main challenge, you can say that the starting point, which is a goal-based regulation, and the end point, which is a safe fallback states, they basically frame it. They frame it very well. So you need to start with the goal-based, risk-based requirements, and then you have the fallback states. The challenge is everything in between. How do you go from the goal-based requirements to specific requirements? And how do you know when you are in distress and need to go to a fallback state? And that is kind of the practical challenge. And I think you alluded to it, John, because you talked about assurance cases. And at least the part that we are researching now is assurance cases that are made early during kind of the concept and the design. And they hold all the requirements. They hold the evidence that demonstrates compliance. And they hold the acceptance criteria. But then you need to keep that sharp during operations, because you will break assumptions that are also built into the assurance case. So that is kind of the tangible way that we implement safety into machine, is through the assurance case. But it's still not easy. But that's kind of the concept that we are trying to follow. So you can say the assurance case is the trust asset, as we call it.
Yeah. Okay, super. I think that's very valid point. I'm happy to take questions. I mean, I see it's... No, we still have time. Please, go ahead. John, if you
just say one thing very briefly. Here. Thank you, Frank. I completely agree with you about that. But I think the other thing we need to do as well is actually work out how to learn from operations. You know, when we're doing the safety assessment, it's a prediction about what will happen in the real world. You can't fool reality. We need to actually monitor what actually happened and say, oh, bother, that algorithm didn't do what we expected, and we need learning processes. And I mean, Jakob Tølling was earlier talking about the need for openness. I think we do need openness about things like that. Something may be specific to a manufacturer, but other maybe some misinterpretations of regulations. We need to be able to share understanding so the whole community can learn. And I think that's an interesting area of collaboration too.
I will just bring in an aspect that you're not alone. The shipping industry is not alone. It's not the only industry where this happens. That AI comes in and disrupts a lot of things. Everything has to be reorganized. Within the aircraft industry, it's the same, and I assure you that that's not the place where you have fresh software. The systems for the beautiful word, graceful degradation. I don't know if that's a word within the shipping industry, but in the aircraft industry, the graceful degradation is the gold standard. Nothing should fail immediately. It should fail in steps.
Okay.
Within the medicine industry, health industry, software now is considered a medical device. And in order to, if you have a software that is doing something about health, you have to basically follow the same protocol, so as if you were providing classical clinical medicines. You have to have research. You have to show that it can repeat itself. You have to show that it works, basically. Finally, when it comes to human interface, which is also very important, of course, in the aircraft industry, I saw on the French Open yesterday that they interviewed the players. They have for many years been in the forefront of technology, taking into use line technology without judges, but not in the French Open. They are looking and watching what's happening. Is it good enough? And basically, last tournament, the system made errors. It made at least 3 errors. You could see it on the screen. The ball is out. The system says it's in. Regulatory, it is in. And they asked the players, what do you prefer, the machine or the human factor? Everyone said, well, the machine. But of course, you're right. It feels worse when a machine does something wrong than when an IT system does something wrong, even if it is better.
Okay. Well, unless you want still to intervene, I would propose that we can also take questions from the audience. Is there any intervention at this last, a bit late, late time in the day, where, no? Ah, yes, over there. Oh, okay. Thank you.
Thank you. My name is Koen van der Merwe from DNV. We've been talking a lot about EU AI Act and the maritime industry, but the AI Act doesn't explicitly mention the maritime industry in its document. Is there any agreement on the applicability of that regulation on maritime applications?
I will not be in a position to reply. Please go ahead.
I don't think any of us have the exact answer, and I'm planning a seminar on this, so I will try to announce it widely. So, but my preliminary view, and there are people from the Commission here, and they can perhaps correct me, is that the starting point is that the AI Act applies, but then the navigational systems would be some kind of a maritime equipment, and there is a special provision in the maritime equipment regulation that was implemented by the AI Act, stating that the AI Act will give only guidance. One should be more flexible than outside the maritime equipment regulation. So that means that there is, first of all, room for any IMO regulations, and secondly, I think it's not of paramount importance that the AI Act applies to maritime AI navigational systems, because there is some flexibility built in here.
Jakob, you want to intervene? You'll be better placed than I am on that one.
Thank you very much. And I feared that question, but Professor has provided you with I think with a very good answer. This is a question that is not uncommon when you do horizontal legislation. And as I said in the previous session, that this is not an act for maritime. It's horizontal for anything using AI. And as it is built into this, there's also, as mentioned by your colleague from this sort of pact, there is also the part of guidance that the Commission is working on with industry, with authorities, to understand how this applies to the various sectors for various special parts. So, and we are at the beginning of the implementation of this. So the answer is that yes, it's a little bit of a gray zone for the moment, but it's no intention to make anything impossible. And I think that is part of the answer from the professor. And that is as far as we can go. It's a framework to be respected for the reasons we mentioned in the previous session, but it is not there to be an obstacle. I think that is as far as we can answer today. And again, it is not a maritime act, it's not with us directly, it is with colleagues, but for such a seminar we will, if invited, try to have the right people to give the overall thinking and framework for this. I'm not inviting myself, by the way.
Thanks a lot. Thank you so much, Jakob. Any other question? Yeah. Oops. Okay, I'll go. Ah, okay. Thank you.
Okay, thank you very much. My name is Erik Tvedt. I'm from the Danish Maritime Authority. But I'd like to just draw your attention. There's a Norwegian research project called the Humane Project, who has been dealing with these issues. And that makes some very good, if you go to the website, they had some very good cartoons. And they describe different situations. And they got a bear who's the captain, and it always ends up with somebody coming and arresting the bear, putting him or her into jail. And I think that's some of the things we're struggling with. We've got a 2,000-year history of having the human in the loop, where we train people. First we give them an education, then we train them, then they work. And we can assure they go to examinations, they've got certificates and so on. But then again, as the lawyer has been saying, if things goes wrong, we go to court. And I'm not talking about civil liability and money, I talk about who's going to jail. That's the penal code. And that's really the core of it, because us as human beings, the way we keep the checks and balances of this is, yes, training, education, and so on, and then punishment. And the big question, of course, if it's a machine and some software, we miss the punishing check on what goes on. And I think that's, to be positive, something we need to work on. How do we address this? One way of doing it could be objective responsibility for the ship owner, because that's actually what's in the legal systems today. You go, if there's nobody else, it's always the ship owner. But I'm not sure that the CEOs of different shipping companies are ready to take that obligation to go to jail if something happens. But this is really the core issue, looking at it as a flag state. Because even if I look at the risk case, look at the assurance case, yes, this might be safe. When things go wrong, and they will, it's Murphy's Law, then who is to blame? And there will be political, legal pressure to appoint blame, no matter what we are saying. And I like to have you a solution, have you an indication of which way we can go with this. Thank you very much.
Okay, thank you. Well, jail may not be the most positive note to finish on autonomous shipping, but okay.
I mean, sort of, perhaps a brief observation on that. One of the things that we've done is actually some work on trying to map the influence of autonomy and AI on responsibility, working with some lawyers and some moral philosophers on that. So we have some papers on how you might analyze how this technology shifts responsibility, which doesn't solve the problem, but gives you a way of thinking about it and saying, actually the responsibility lies on somebody we don't think it should, and that suggests some changes to the regulatory or legal framework. Happy to share that with you if you wish. Almost positive.
You want to say a word?
I'll just be positive in the meantime while it's going through me. I think, as I said, the value for society and every actor is so big that by many, many small steps we will get there.
I'm not sure that I feel the need for some kind of criminal or tort action against a tortfeasor here. But if one needs that, first of all, one could have strict liability, no-fault liability, as you mentioned. The problem here would be that the Collision Convention on Liability for Collision from 1910 prohibits that. So we have to rework that whole area of law, but that's possible. And then there is also criminal law, and in Norway, as one of the quite few countries, we can actually criminalize corporations, and they are not put in jail, but they will get substantial fines. And that will serve the need. Many people feel that if, for example, a ship owner, a ship-owning company has trusted a faulty system, then they could get some criminal reaction on that. That is, they could get a substantial fine.
Okay. Maybe a last one then. No, I still have two. Okay, but we take still two questions, because two questions from ladies. Otherwise, artificial intelligence is really like a men thing. See the panel and okay.
Hi, I'm Dipali. I'm from Lloyd's Register. I work as a product manager for autonomous ships. So I'm electrical engineer anyways by my profession. My question is, first thing I really want to say about the EU taking initiative on having AI. And I completely agree that we need to have AI standardizations irrespective of the type of industry, but what goes into it in terms of traceability, evidence gathering, in terms of changes management. So I think there has to have some common framework in terms of AI, irrespective of the industry. Second thing is, when I was looking into, we have seen that for maritime industry, it is always about going from point A to B without having any collisions. That's what we call safety. So, and that was driven by the CDCA, which is collision detections, collision avoidance, coal reg requirements, irrespective of type of the vessel. So I think it is very important to have CDCA, which is much explainable. Right now, it is very much with the human interpretation. And we have never checked if Master A has an interpretation same as Master B or Master C. And by doing a lot of work, we have seen everyone has a simple, very different interpretation. So we never checked that in the past. We still left everything to the human assessment. So here we have a chance to create certain rules which can be explicitly mentioned. So I think we have to really rethink what we were doing in previous. And of course, we are leaving so much to the human, which goes through a lot of stress, have to handle multiple systems. And with innovation, you are going to have that more and more challenges, having multiple systems which human has to look. So obviously that human, apart from his whatever problems he's carrying, he is still having the fatigue, the human error because of that. So I think it is really a question we need to ask, is this an opportunity or it's a danger? And I think we have to think this is an opportunity and create some more explainable standards. So that's really my take. And of course, it is also an opportunity for legal and insurance, because you can always look into the system of system engineering to really go through each of the systems. So it's a challenge for owners to really, you know, what we have been we are leaving it to humans to do all of it. Why not you get your systems in place first, doing it correct design? So I would say that take this as an opportunity rather than just, you know, with the giving good challenges. So that's really my take. And yeah, it's just a ask to most of the panelists. Thank you.
Thank you very much. Maybe we take the last question and then I give you the final word. Just here, yes. Yeah.
Hi, Maria Cortinaz from DNV. It's a bit related, not fully, so I might put the panelists in a difficult situation now, because I wanted to go back to the updates question. We see that these systems, they are updated much more often than current maritime equipment. And as maritime class, we have an established system to check this update and make sure they continue safe. But we can see that an algorithm can change completely from one update to another. And how are we supposed to check that they still do what they did on the beginning when we checked? Are we supposed to keep continuous checking? And this is a question that we have and that we are working on. But since I have so many specialists here, I would like to know your opinion.
Okay, thank you. I think there are drinks, so you have to answer in 2 sentences to those difficult questions and remarks.
So be very brief. Explainability is very important. There's technical AI explainability, which actually isn't very useful for human beings. We need to work on human-centered explainability, and I can explain more if I say. About the continuous updating, you're right. It's a huge problem. In AI, they have this term catastrophic forgetting. It used to know how to do something, and it doesn't anymore. There are people working on ways of fixing that. They're not part of the mainstream. So the positive is any research funders, that's a really good problem to spend your money on.
From a legal contractual point of view, this is what we have today. You have big systems doing very sensitive stuff, being updated and upgraded. If you, for instance, do a big upgrade, you have to do a new assessment under the GDPR, for instance. So we just have to do it anew, depending on the risk you are taking when you do the update. If it's small, you don't need to do it. If it's big, you need to do a retest.
So I think we need a clear framework, we need standards, and we need to ensure that the operators operating do know that the system is up and running. So it's quite complex. I'm not a lawyer. I see that we will still need lawyers in the future also with AI automated vessels. Because so again, kind of down to the safety of the ship is the capability of the operator. So I think that keeping it simple for the operator with all the complex frameworks in background is the way we need to go.
I'm so glad that the update question is an engineering problem.
Maybe we can have a lunch talk tomorrow. But I think the solution lies in what Øyvind Smogli said about modularity, and then establish modular contracts between the different modules and then do monitoring. I think that's the only viable option. And of course, what you monitor is the assurance case that we just talked about.
Okay. Well, our panelists have been, you have been fantastic. Thank you so much. So, yes, let's have a round of applause. Well done. Okay.
Tack. Okay, thank you to the panel. We are at the end. I'll try to make it as brief as possible. There will not be drinks afterwards, so you don't have to hurry for that reason. I think we first will look at the Slido stuff from 2024 and what we got today, and representation, government institutions, other. Can I have from next? Yeah, more or less the same, perhaps a bit more into developers and researchers. So it remains a quite wide type of audience. Next, please. And this when do you expect the first fully autonomous? After 2040 was the main result from 2024, and then gradually decreasing towards before 2025. Next. And as I said previously, this is, in my head, quite interesting because the opinion has moved close to 10 years. It's quite fascinating that we see that there is actually a much higher optimism in the industry today. And that's something to keep in mind. And I think actually the two first sessions we had today, talking about non-mass applications of autonomous ships, is part of this explanation. We see that these things are coming into other areas than international shipping. So that's interesting and worth keeping in mind. For what trade? Short distance shuttles was the main one, short sea following. Next. Still, short distance shuttles, which makes sense in my head, and the short sea also following. So this is more or less the same as previous. Next. Which type of ships? Cargo, passenger 13, other 33, which also is not a big surprise. Please, next. This, okay, we didn't ask it quite like this last time because research and offshore was just in the other category. But that has, again, kind of gone over the maritime cargo, which I think also is dependent on recent results we have seen, particularly in this USV business with intervention, small intervention vessels, survey vessels, and so on. Next. What impact have we from the mass code? Medium was last year's answer, 50%. Major, 31. Next. There we are. Well, we don't have any. We didn't have any answer to that, so I guess we just have to stick to the previous. This one is also interesting, I think. Do you think the human will become redundant? And I think also, looking back to the presentations we have today, my impression is that most people believe that the human still will play a very important role in autonomous ships, not the least in kind of being a backup for these advanced automation and AI systems. And I fully agree. And I think actually that one of the overlooked issues in both in IMO and in other research on autonomous shipping is this: how do the human and automation interact? And how do we safely change control from or between humans and automation? So this is absolutely also worth keeping in mind, I think. Next. Here we have one we had in 2034, and which I believe we answered also here. Would you go on board and sail with a fully unmanned ferry? 72, yes. 28, no. Next. And now we have 83, which I also find, okay, it's, I have to analyze it whether it's statistically significant, but I think also this reflects quite a bit that there is significant trust in this area, and perhaps growing. I'm not sure if you can say that from a scientific point of view, but just looking at the numbers, yes. Next. This was only on 2024, so it was, would you be prepared to play a bit more for cargo on autonomous, not autonomous, but zero accident, zero waste, zero emission ship? 50-50. So we let that be for now. I could try to summarize, but just to be brief, and I've said it before, I think it's quite interesting to see these new applications in large USVs and in passenger ferries driving quite a significant number of projects in the non-mass sector. So that's something worth keeping in mind and also keeping a watch on. And I think also, as has been pointed out, that this may be a very important contribution to the work on mass. These are relatively large and critical vessels. Safety issues are similar. So a lot of interesting developments here. Another point which I mentioned before is the importance of real business cases. If you want to develop something, have a real business case and then develop this system and preferably simplify the system according to the problems you are trying to solve. Don't overcomplicate. It's bad enough as it is. So keep to good business cases and make systems as simple as possible, and that also includes using the human operator in a sensible way, effective way. One point also worth taking note of is the discussion from the road ferry industry, that you actually can use public investments to improve, or at least in the long run, improve services and the effectiveness of the public service, but also to drive innovation. I'm not sure if this is a special Norwegian feature or Swedish feature, but we should look more at that. The public authorities are spending quite a lot of money on transport systems. They might want to have a look at also helping innovation in the sector. And then over to AI and what we have recently been discussing. I think the general agreement from the technology sector, that's the first or the third session, is again more or less keep it simple and not necessarily stupid, but at least controllable, understandable. Modular, not too complex, not these big black boxes. And from the last section, that even then it will be complicated to get approval for these systems due to the nature of AI. So that's what I'm planning to say related to the 6th Autonomy Summit in 2025. And I will give the word to Fotini, which is, in lieu of Magda not being here, responsible for the next event in 2027. Please.
Thank you very much. So, thank you very much for giving me the opportunity to say the last few words to close the event of today. And I'm conscious that I stand between the drinks, so I will be very short. First of all, to say that it has been a great pleasure for me to follow the exchanges here. I have my notes on what I'm coming back home, but I'm not going to share them with you, except if you want during the drinks. I would like again to thank you NFAS, thank you Norway for hosting us, thank you Norrshipping for hosting us, and thank you to my colleagues that have also worked hard to have this summit a success. And I would like to invite you next year to the EU for the 7th International Summit in a city to be defined and at a date to be still defined, but as soon as we know, we are going to let you know, so stay tuned. Thank you very much for being with us today. Thank you very much to all the people that have intervened, to our panelists for the great exchange, and see you next year somewhere in Europe. Enjoy your drinks.